everyone, I'm João from That's Brilliant, and this video is another video on calculus. So the last video we proved the derivative of sine. In this video we're going to prove the derivative of cosine. So the proof of this video is very similar to the proof of the last video. And by the way, I'm going to put the link of the last video in the description below. But anyway, let's start the proof. And as I said, this proof is going to be kind of similar to the last one. So we're going to start in the same way. We're going to start with the definition of a derivative. So if we have a function f of x, the derivative of this function, which means f prime of x, is equal to the limit when h approaches 0 of f of x plus h minus f of x, and divided by h. This is the definition of a derivative using limits. And we're going to apply this definition to the cosine of x, which is the function we want to calculate the derivative of. So, in this case, f of x for us is cosine of x. As I said, we want to calculate the derivative of cosine of x. So for this video, f of x is cosine of x. So f prime of x is what you want, the derivative of cosine. And so let's move on with this definition. We're going to apply this definition to cosine of x. So this is equal to the limit when h approaches 0 of, well, if f of x is cosine of x, f of x plus h is cosine of x plus h, minus f of x, so minus cosine of x, and this is divided by h. So this is equal to the limit when h approaches 0. And before we move on, we have to remember of a sum to product formula. So last video we used one of those equations that transform a trigonometric addition or subtraction into a multiplication, into a product. And we need to do that so we can manipulate things and simplify our derivative and prove the derivative of cosine. There are different ways of doing this. In this video, we're going to use a formula of sum to product, the same way that we did in the last video. But this is a different formula because in this video we have cosine minus cosine. In the last video we had sine minus sine. So we're going to use a different sum to product formula, which is we have cosine of A minus cosine of B. This is equal to negative 2 times sine of A plus B over 2 times sine of A minus B over 2. This is one of the sum to product formulas for trigonometric functions. Now, we studied this when we studied trigonometry. So let's use this formula here. So we have cosine minus another cosine. So this is going to be negative 2 times the sine of A plus B over 2. Before we move on, let's identify what is A and what is B. So A is the argument of the first cosine, of the positive cosine. So A is equal to x plus h. And b is the argument of the second cosine, the argument of the negative cosine. So b is equal to x. Now we can move on. So a plus b over 2. Oh, let's start with a plus b. A plus b is x plus h plus x. So it's 2x plus h. This is just a plus b. Then we have the divided by 2. And then the sine of a minus b over 2. So a minus b is x plus h minus x. X cancels out with negative x, and we are left with h. So h and this is a minus b. Then we have the divided by 2. And then all of this divided by h, this h right here. So this is equal to the limit when h approaches 0. Before we move on, we have to manipulate things so we can simplify this whole expression. So the same way that in the last video we remembered of a famous limit, we have to use that same limit in this video. So we have a limit that says the limit when h approaches 0 of sine of x over x is 1. So notice that we have the sine of x of h over 2 divided by h. If we had a divided by 2 here, we could think about applying this limit. So let's manipulate things so we can do that. So what you're gonna do is, if we divide both the denominator and the denominator by 2, nothing changes. So if we divided this whole thing, the whole numerator by 2, this 2 cancels out. And when we divide the denominator or h by 2, we get h over 2. We divided both the numerator and denominator by 2. So here we have h over 2, h over 2. We are getting closer. Another thing we can do, we have a negative sign here, which is just a negative 1 multiplying this whole expression. We can put this negative 1 before the limit, out of the limit. So we can put this negative outside the limit. So here, negative. And another thing we can do, can use the same property of limits that we used in the last video. So it's a property that says, when you have the limit of a product, this is equal to the product of the limits of the factors that were being multiplied before. So let's write that. It's going to become clearer. So the limit of h, when h approaches 0 of, let's divide this limit into 2 limits. This one here in red, so this is the sine of 2x plus h over 2, and then multiplied by the limit when h approaches 0 of sine of h over 2 over h over 2. So this is the second thing. We divided this whole expression into 2 limits. So these 2 factors were being multiplied together. And we had the limit of this whole thing. We can divide this bigger limit into 2 smaller limits, into the limits of the 2 factors we had being multiplied together. So we're getting closer. This limit here is what? Well, you can say this h should be divided by 2. Yeah, but it is the same thing. When h approaches 0, h over 2 also approaches 0. But let's just do this with more detail, just to be more mathematically correct. So let's do this limit here. We have that. Let's say that h over 2 equals u. So when h approaches 0, u also approaches 0. So this limit is the limit when u approaches 0 of sine and h over 2 we called of u. So sine of u over u. And this is obviously 1, right? Because we had limit of h. Limit when x approaches 0 of sine of x over x is 1. So if we just call x of u, it's the same thing. This is 1. So this whole limit here is 1. And we can forget about it because multiplying by 1 doesn't change anything. So moving on with our math. We have the limit when h approaches 0 of this whole thing. When h approaches 0, this h here, this looks like a b, but it's h. This h here is approaching 0. When this h approaches 0, this whole expression approaches sine of 2x over 2. And we have this negative sign here. So negative sine of 2x over 2, which is just negative sine of x. And here we have just proved the derivative of cosine of x. So we can write it here. So cosine prime of x, the derivative cosine, equals negative sine of x. Or if you prefer, ddx of cosine of x, the derivative of cosine of x, equals negative sine of x. So this is it. We have proved the derivative of cosine of x, which is just negative sine of x. Thank you very much for watching, and I will see you in the next video.